All right, there are a bunch of intelligent talks by really smart people on completely industry-changing ideas and methodologies and things like that. That is not one of these talks. Absolutely not. This talk is really just going to be a bunch of super practical, oftentimes hilariously simple and stupid techniques that work in webappsec. So I'm just going to burn a bunch of our defensive techniques because, yeah, YOLO, as the kids say. Cool. All right. Like I said, I run security engineering at Etsy, which is a few different teams there. I spent most of my background in offense. And I want to give a shout out to the full team because they're like, I may be the one up here talking, but it's the vast majority of this talk was these guys. So like I said, obviously, oftentimes amusingly simple techniques that actually work in the real world. So everything I'm going to talk about here finds real bugs and real vulns. And specifically, we're going to focus on how do you detect when vulnerabilities get discovered. So knowing when, all right. So how do you know when someone's looking at your app and just found a vuln? And we're going to run through that for some different vuln classes. And then we're going to talk at the very end about how do you increase attacker cost in a few different ways. How do we make it more expensive for somebody to go find vulns in your app? So like I said, how do I know when someone just found a vuln? The joking name that we get to use for that is unintentionally responsible disclosure. So thinking about it, and here's probably one of the few parts of this talk that's kind of methodology side and kind of bigger picture side is thinking from your different vulnerability classes, what signals get created when a vulnerability is discovered and then when a vulnerability is actually exploited. And taking a look at it from that side and thinking every vuln class is actually going to trigger some sort of signal in your application that's being discovered or that's being exploited. And let's run through some of those signals and come up with some practical things for that. And you instrument, it's not just the server side. That's what's kind of interesting is you don't just instrument the server. In places where you can, you instrument the client too. Even when the client is hostile. It shockingly works a lot of times to instrument a hostile client to maybe give you a heads up that they just owned you. So I'm going to run through examples for XSS, SQLi, and remote code execution. And then I'm going to jump into at the end of the talk about increasing cost. And I hope that I time this talk right so that there's it'll probably be fairly quick and we'll have questions and things like that because I'm sure that statements like these are going to cause questions. In fact, you know what? It's probably going to run quick enough that shout out questions. Shout out bullshit when you think it's bullshit. Cool? Okay. Let's take the most common, we're jumping into XSS first. Let's take this is the most common testing pattern from looking at our data. So this is the most common XSS testing pattern that we see in our application. And it's the very trivial one, right? You inject this HTML, there's no image name X, so it triggers an alert. It triggers an error, that triggers an alert. You pop that up and you're like, okay, great, I just got execution from the HTML side. So what's the first thing? Let's break this down into how this actually works. You're inserting, if this tag actually executes, if you win as an attacker here, it's because this image tag just executed in your browser. What happens there? Well, the first part that happens is you try to load an image named X. What does that look like on the server side? There's a get to X. What does it almost certainly look like? A 404 in your application. Because that X doesn't actually exist in your application. So we went back and we pulled 30 days of attack data out of our app. And we took a look at, in the 30 days, there were almost 7,600 attempts to inject an image tag. There were only 72 different source targets for that. Almost, 50% of them, when you walk out, are three things. Do you think in a major web application, XYZ, X, or 1 exist as an endpoint? They don't. We ran an experiment on this. And the things that we learned out of this were that this hilariously found people finding XSS. Because what happens is, when you inject that image tag and it works, your browser doesn't get to /x. There is no /x in your application. If you alert off of 404s to /x, you just notice that somebody found a XSS. The majority of false positives, when you turn this on, all come from one class. They all come from search engine crawlers. You can, in the first 24 hours, whitelist all of your search engine crawlers on this, and then the only things that come in are actually real bugs. It's hilarious. Alerting off of a request to /x in your application actually works. All right, let's go back and let's look at this again. What happens next? After you do the get for /x, what happens? Shout out, it's not a trick question. Straightforward. There's an error, right. It doesn't load, so you fire the on-error event handler. You do an alert 1, right? Cool. So what I just said a minute ago of don't just instrument the server side, instrument the client side too. What happens here? An alert 1 fires. How often do you think an alert 1 fires in a real web application? Well, actually, I'll get to that in a minute. Funny story. But, right, your first approach then is, OK, this never happens. Let's override alert, and let's tell it to phone home anytime it ever executes in my application. Because alert 1 should never, ever happen. I want to give props where it's due here. Facebook, we had some discussions with them. Turns out they came up with this in 2007. We came up with this independently in 2012. One of the awesome dudes at Facebook, Mindframe on Twitter, if you don't follow him, you should, did a talk at LASCON last year that was awesome, and this was one of the slides. And then we're like, oh, shit, well, they just burned it, so we'll talk about it now, too. And we went back and forth on Twitter a little bit, and then we rolled it out. And so that's what I want to talk about is the results. These are the actual results of overriding alert and having it phone home whenever it executes. It's a highly technical diagram, as you can see here. So let's go back. This failed spectacularly because of false positives. We turned it on, and it just started flooding instantly. And the reason was, when I said a minute ago, like, oh, how many times do you think your application really calls alert 1? Well, we should have checked that, actually, before we turned that on. Turns out our application called alert 1 a decent amount of times, which is embarrassing. So let's go back, and this is going to be one of the major themes to walk out here with, which is that the whole kind of, let me get buzzwordy for a second, but it's the shortest way to say this, data-driven security. Taking a look at your data and not just the assumptions of how you think attacks work. Because often we're totally wrong. Or we think that they're going to work with this way, they're going to work a different way. Or they do work that way, but there's also tons of false positives there. So looking at your data, collecting that data, then looking at that data and see how attacks are actually happening and what are the unique signals out of that attack data. So overriding common methods, cool. But we're only interested in really what are the payloads to those. That's where it starts to get to unique. So we pulled 30 days of attack data again. And we looked at, there were 8,500 XSS attempts in that with alert, prompt, or confirm. Those are the big three. That's 99.9999% of your XSS attempts are going to use one of those three. These numbers are a little bit misleading, quite honestly, because the huge spike in prompt on that is not what you actually see in a real web app. The majority is still alert. It's followed by prompt and confirm. It happened to be during those 30 days, there was this one just astronomically large scan that happened to use prompt, so it skewed the data there. And then sometimes you actually see them with both, or with multiple ones. You'll see like a long string that in one area attempts to do an alert and the other attempts to do a prompt. I have no idea why, but you see it. So let's look at the data from there. What are the payloads we're interested in? Again, you watch the top ones happen, and then you watch it fall off a cliff of just long tails of ones that you could never hope to instrument. Far and away, XSS, document.cookie, and then integers. Integers are because of scanners. So when you do a scanner and it's a headless thing that's crawling all over a web app, you need to, if you trigger execution for XSS, you need a way to map that back to what form field that was or what input that was. So you do a unique identifier for each one, and then you keep a dictionary of that, and then you see the results come back, and you say, okay, 1,153 just fired. That was this input. Let me throw that into my results. And you just watch incrementing ints go by, and you're like, okay, cool, it's a scanner. One like weird lesson we learned out of document.cookie is you can't just look for that string. Any of the document objects in JavaScript, by the time you can go and do like a string match on this, it won't be document.cookie, it'll be the contents of. And so what you actually have to match on for document.cookie and document.domain and things like that are the contents of. So if you want to match on document.cookie, find one of the unique cookies in your environment and match on that string, because that's the only thing that you actually can match on. Same with domain. Match on your domains, not on the literal string. We couldn't figure out why that wasn't firing for the first day or so when we were testing, and then the magic of printf debugging, you learn. So we ran an experiment off of these three. Hilariously, finds real bugs. We thought that this would find a real bug once, and then there would immediately be a blog post on us doing this. There hasn't been. Which is awesome. No one take that as a challenge or a thing to tweet. Just being open. it needs adjustments in the first few days. You'll have areas of your app that are maybe like you think are debug code or something like that, but it turns out it gets hit by 1% of your user base, and at scale that becomes a ton of data. You whitelist it real fast though. Like this, in our case, it was spend about the first 24 hours on it, whitelist a few things, and you're good. So what else does a good job of detecting XSS? And we're going to stay on the client side for a bit. I want to give them a shout out. Google Chrome's XSS auditor thing sounded like a laughable idea when first heard it. It's totally awesome. Like, props to them. It's good stuff. So Chrome XSS auditor, I could probably spend too long on this, and I'm probably going to get this wrong anyway. The TLDR is that there's some code built into Google Chrome that essentially it's scoped for a very narrow set of attacks, but it does a pretty good job of them, which are reflected XSS attacks that happen in HTML. So either inside HTML or the creation of new HTML elements. They don't try to solve JavaScript because that's actually very hard. And so they focused it for this, and they did a really good job of it. So you essentially, and this is the part I may have wrong, but conceptually, it's close enough. You record the parameters that are sent in a request that ostensibly come from the user, and then you compare about what shows up in the DOM. And if there's something that comes from the user request that then creates like an HTML element like that, you strip them out. And so this is like your classic search engine thing of like Q equals script alert 1. When that comes back into the DOM and triggers as HTML and executes, they strip it out. And that's why when you're doing like pen testing with Chrome, you go in and you disable this feature as the browsers are doing more and more of this. And I think Firefox is starting to do this too. I know NoScript does something similar like that. It's awesome. They really deserve a shout out on that. The problem here is that ultimately you're running a losing game. Well, you're winning the game that you're trying to play, but ultimately Chrome can't fix XSS in your application. And the user can't. Like you can defend the user against a lot of like basic things, and that's awesome, and we should be doing that. But how can we, as application owners and defenders, use this same principle and get some like cool value out of it? So you can use the same thing. How can we do it on the server side? What you do is you scan input, gets in your posts and things like that for HTML escapes and for tag creation. If it exists, you set a flag and you say, okay, this input was potentially hostile here. It's trying to escape, it's trying to create. Cool. Set that flag to true, and then build up an array of what all of those look like. So there was a double quote, close bracket, script alert, open bracket, script alert 1. There was a quote on error equals alert 1. Whatever it was, build that up into an array. At output time, right as your output's flying out the door, check that flag. If it was true, then iterate through the page that's going out and see if any of the hostile input that was in that array is actually as valid HTML in the page. If it's live inside of a tag, if it's its own tag, whatever. And if it is, you fail open here actually. There may come a point, we're too early in our testing on this to say for certain what comes of this. There may come a point where you start to do the Google approach and just strip it out and get very proactive there. I'd be shocked if we end up doing that just because the cost of failure is kind of high there. You're kind of breaking your app. But you can sure alert. Like, you go from here, and if that's valid HTML that's going out the door that's in one of those requests, you just found reflected XSS in your app. And the important part here is maybe you do the risk trade-off of maybe I'll break my app, but I'll stop some reflected XSS if your time to patch is very high. But if you're dealing with an app that's got on a 6-month release cycle or something, in the same way that you then use WAFs and those sort of things there, if your time to release is very quick, right? If pushing to production takes 20 minutes, then cool, detection works great there, right? By the time you discover this XSS, and by the time you actually attack your target, it's almost certainly going to be more than 20 minutes. You got to go build up the payload that you really want. Like you just found XSS with script alert 1. You need to go build up the payload that you want. You need to get your target to click on that if that's like a targeted attack, or you need to build up some sort of worm if you're trying to just go for mass propagation. And yeah, if you can patch quick enough, then you just patch and you kill it. All right, let's talk about Bobby tables, our favorite friends. Let's go to SQL injection. So let's talk about anomalies along the actual attack chain of SQL injection. There's kind of this, I don't think it's a misunderstanding. I think it's that we just kind of gloss over the fact of from when you discover SQL injection vulnerabilities to when you actually, the time from tick_1 equals 1 to pastebin is actually a timeline, right? It's not instant. It's not, I just found a verbose SQL error message and now I've got the full table. There's an attack chain there, and we can instrument that attack chain there. So it starts out with this. This isn't the attack, this is the discovery. This is SQL syntax errors showing up. I've talked about a few of the things in this section in some previous talks, but I think they're both A, really important, and B, really effective. And so I'm going to go back over a few of these. Because this is one of the best things you can do that you can almost certainly turn on today. Alerting on SQL syntax errors showing up in your application. It's almost certainly already in your error log. It's incredibly high value, even if it isn't a, right, this is near that. That's some generic bug that, well, knowing what I know about our stack, this isn't exploitable, but it's still a bug, right? And you'll start to see that in your stack very quickly of, okay, here's a bug that's not exploitable, let's fix it. Here's one that, oh, wow, yeah, okay, that one is exploitable, let's go fix that immediately. And the important point is they're all bugs. Some of them have serious security implications, some don't, they're all bugs. Moving down the attack chain, this is looking from the attack side, is you need to figure out what that database is. Where are the tables that contain the information that you want? What are you actually going after? You need to map out all the table names and things like that. From the defense side, what does that signal look like? Almost certainly your application doesn't request sensitive table names as part of a Git parameter. When your user sessions table shows up as a Git parameter to your search query, you probably want to know about that one. It's probably a little unique. And the important point there is actually the fact that that's unique and not even necessarily an attack. And that's what's cool about thinking about this from anomalous signals and looking for anomalies, is that if they are anomalies, false positive cost is extremely low. The cost of looking at an email that says sensitive table names just showed up in a request here is almost nothing if it happens once a week, because you look at it and you're like, oh yeah, that's false positive, obviously. Or what's that? I need to go check that out. But when the cost is so low, it's crazy to not do it. Finally, kind of near the end of the attack chain, and I'm kind of jumping over a few things here, but at the end of it, a response containing your database is orders of magnitude larger than a normal response, right? A search for kittens and select star from user table, wildly different response sizes. When anomalously large responses start going out the door, that's another incredibly interesting alert. In modern applications where that starts to, the little devil in the details and the trick on this one is that lots of our applications do have endpoints that result in huge response sizes. You either whitelist those out because you've code reviewed them enough that you're like, all right, that's cool. Its job is to return this one file or this one thing. It's going to be large responses, but I'm cool with it. I think it's good. And so that's how you actually, that's what you deal with in the first week or so of this as that functionality gets found. You whitelist those, you go from there. The point of all this is not to just alert in one spot. All of these are interesting by themselves, but they're incredibly valuable in a chain. The more that you do, the more context you have when you start to look at it, and the more clarity you have. Because, like I said, false positives happen, and they happen all the time in production infrastructure. So, let's look at this from the alerts I was talking about here. You have a SQL syntax errors alert in place. That's deliberately gray. It doesn't go off. You have a database table names alert in place. It suddenly goes off. No large response sizes ever go out the door. Obviously, I'm oversimplifying here a bit, but this is false positive, right? But the fact that you have these 3 alerts or n alerts means that when you feel that you've instrumented the attack chain fairly well, and one in the middle goes off, then you know, like, okay, well, odds are this is a false positive. I'm still obviously going to treat this as real and go analyze it and go take a look at it. But the fact that SQL syntax error, thinking from the other side, if SQL syntax errors goes off, and then database table names start appearing like a couple hours later, and then a few minutes later, large response sizes start appearing, and then around the organization, this face starts appearing, you know that something's actually going on, right? And every alert that you have along this chain increases your confidence that you know that something's going on. All right, remote code execution. Like I said, shout out with questions. I'm flying through. So does anyone remember this Reddit post from like a month or so ago? It was like everyone just started trolling with it. It was amazing. It was somebody asking like, hey, is this code good to create users for my web application? And it would just pipe input directly into the shell. And so the Reddit comments were it was just an entire thread of this. It was spectacular. I like the one about the permission too, is like something like, oh, just couldn't create a user account at first, so I just like sudoID'd everything, or yeah, sudo, yeah, it's awesome, yeah. Yeah, it's called YOLO.php. Okay, let me go from making fun of someone else to making fun of myself, which is learn from our pain on this one. So if I can give you one statement here, it's even the code that you want to be permanent in production is nowhere near as permanent as your temporary debug code that you forgot about. One of the worst vulns we ever had was some temporary debug code that was in production. And we went and we looked at it, and it essentially allowed, this is, again, where it gets embarrassing. It essentially just took, just like the previous one, it took like a URL parameter and just piped it to system. Like, it just straight up executed. And it was behind a bunch of things that you had to have some special access to get there and stuff like that. But it had like a specific ticket number in the code, like, oh, this is to do with this deployment because this is the only way we can test this one thing, that it's out on this certain web server, and like, it was totally with the best of intentions. It wasn't just like somebody pushed something like that to production not thinking about it. They knew it was dangerous. It referenced like a whole ticket around that, and it was like, remove this in a week. The date stamp on that was 1.5 years, 2 years or so ago. And it's one of those, what's great about this is it had the easiest patch you ever get to do, which is just git rm, right? And it's just gone. But it got us thinking about this, like, holy crap, that's scary, right? This is one of the worst vulns we've ever had. And it was one of the simplest, and it was just absurd. How do we go about automating this to try to find this? Like, what are the alerts that should have woken us up in the middle of the night if something like this ever existed again? And it turns out I'd say everyone in this room already has the tools to find exactly that sort of vulnerability pattern. And it's your access log. I'm jumping ahead a few slides, but looking at where your traffic goes and alerting where it doesn't. So what you do is you map, so you take your htdocs, or your production root, right? And you build up a list of files in that. And then you take a look at your access log and you map requests to endpoints. And endpoints that don't get requests are anomalous. If you have a production website that has an endpoint that has had less than, I'll make up a number, 1,000 requests in a month, that's dead code. Like, that is completely dead code. You can go look at the access log. That's going to be entirely search crawlers and things like that. Hopefully not search crawlers, because then somebody can find it, but probably search crawlers. Dead code, kill it. Don't kill it automatically, alert off it, but the awesome thing about this and alerting off of it, yeah, like I said, it's still reachable and everything. The awesome thing here is you pay a one-time hit to go review all this. So you build an alerting mechanism that says anything in the last month less than 1,000 hits alert. That first month you get a whole array of like files to go check out. That's your code reviews for the next couple days. It's really nice because you can look at it and be like, nope, dead code gone. Clearly debug file gone. It's like very quick code reviews. But then the incremental change off of that is almost nothing. Right? Your one-time hit is bad. You spend a couple days for your AppSec team. And then next month you have 1 file or 2 files. Like, it just drops off a cliff. All right, let's make it rain for attackers. All right, cheapest way to find web app vulns. One word. What's the answer? Google? Yeah, that's okay. There's apparently a lot of one words that are a good answer, right? I was stalling because I needed to take a drink. Automation. So yeah, kind of Google. If we want to think about this from a way of economic costs for attackers, the more they can automate, the cheaper that it is, just like for the rest of us. Think about it from the economic side. So how do you kill the spots in their tooling, like in their tool chains, so that automation goes away in as many places as you can kill it? How do we force attackers to be manual? Now, some of the dirty secret of what I'm going to say here is that, well, your best attackers are actually doing things manually anyway. That's fine. What you're trying to do is raise the cost of attacking your application, because a lot of your attackers are going to be financially motivated, and the more cost, if I have to go develop custom tooling to attack that person, and I can do everything off the shelf and attack that person, and I'm financially motivated, I'm going after that guy. Require manual effort. So let's talk about breaking off-the-shelf scanners for a large-scale web application. It's going to sound trivial at first. There's a little bit clever bit near the end, which is that, so every off-the-shelf scanner all of them give off incredibly strong detection skills. There isn't, I don't think, a single one on the planet whose job is to evade detection because they have to get that breadth and that coverage. And it's things as basic as user agents, like we're all familiar with. Although what's hilarious is the number of people who don't change user agents on their scanners. And you're just like, oh, hi, SQL map. It's been seconds since I've seen you. How's it going? To attack patterns. I forget which tool this is. I meant to look this up. Someone in this room probably knows. There's one of the security scanners. It tries its brute force protection or its brute force detection by logging into the Smith account. You just watch these things all day, every day. It's like somebody really loves the Smith account. Totally thought about finding that tool, seeing what the first password it tries is, and just setting that password for a generic Smith account that means nothing, just to troll it. But yeah. That camera's on, right? Yeah, okay. And then things which just flat out don't exist, right? You're a Java shop or you're a PHP shop, request to ASP, those aren't legit, period, end of story. Requests for any sort of technology stack which you don't use, they're not legit. So these are some of the incredibly strong signals. There are weaker signals and there are different signals too, but thinking in terms of categories, these are kind of where it's at. That's the trivial bit, right? Detecting a user agent, not hard. And your first intention there is like, okay, well, cool, I detected, I block. That breaks things. That breaks things really quickly. It's one of those that seems easy on the surface. Shared corporate firewalls, mobile gateways, like you're going to legitimately break way more stuff than you think if you just go do that. So what we stepped back and realized is we don't want to block IPs. IPs are not a strong correlation to identity anymore. They might not have ever been. What we want to break are scanners. And only that. How do we focus on that? So what we did is we went back and we said, okay, for every request entering the stack, which sounds like a performance nightmare and actually, shockingly, is not, classify a request when it comes in, is it a scanner or not? Boolean, yes, no. If it is, assign a weight to that based on confidence. So some of these things, I don't map this back incredibly well, but a request with SQL map as a user agent, that's a scanner, period, end of story. Your ones that are like regexes for cross-site scripting patterns and things like that, you assign less confidence for it. But what you do is you then request, when a request comes in, you say, scanner yes or no. If yes, feed that into a rate limiter. You never thought a talk on rate limiting could be interesting until you went and read Mr. Nick G's talk on rate limiting. It's actually awesome. And it's something that you should be using so extensively in your application, like everywhere. It's like graphing, right? It may not be somebody may not be watching that graph, but you want that graph there for when you need it. Rate limiting is the same way. It costs, once you develop like a good rate limiting library in your framework, it costs almost nothing to deploy it everywhere in your application. It's awesome, absolutely do it. Nick has a good talk on it. So feed a request. This request is a bad request, right? A scanner request. Feed it into a rate limiter. If the rate limiter is above a certain threshold, so we've seen a number of scanner requests from this IP. Cool, drop it. It's done, right? Above a certain request, you just lost that IP for your scanner. And this is how you start to. This is a bit that I didn't go into in the slides, but this is how you increase cost on it, is you start to make them, if you feel that you have a pretty good handle on mass registration and things like that in your systems, you want a expensive resource for attackers is IPs. Not necessarily at like 1 or 2 IPs, but if you suddenly can get, I'm throwing arbitrary numbers here, but if you can suddenly do 20 requests out of Nikto or some off-the-shelf scanner, and then you have to cycle an IP, and that tool is going to generate, like by default, 1 million requests, good luck, you're done, right? You're not going to go through enough IPs and develop the custom tooling to have to do that to just scan a site. Like, forget it, I'm not going to scan it. I'll go just poke around and type script alert 1. It's not that hard. So if it's above that threshold, drop. Oh my God, I forgot to put in the most awesome part. So when we drop them, we actually, so from Etsy, Etsy's all handmade and vintage and everything like that, right? When you trigger the threshold, we now return a HTTP 439 request not handmade for scanners. It's awesome. There were high fives around the office when somebody thought of that one. So it's cool. You don't block the entire IP. You block scanners via that. Now, the design goal of all of this was this. Don't worry about the text on there. It's not important. The design goal was that if you are scanning in your terminal window and browsing Etsy in a browser, your browser should not be impacted in any way. You should still be able to use the site legitimately, and just illegitimate use drops off. And the funny thing is, what we've seen from some of these scanners is that they don't even really realize that they suddenly just hit a wall of HTTP whatever response code, so they just keep scanning. But it's fine, because you've completely killed that data set. Lessons learned from it: set your initial thresholds high. The cost of, you don't care if a scanner gets 50 requests or 20 or 100 or something like that. What you're killing is the aggregate. You're killing the 2 million requests. Your automated scanners are going to go nuts on this anyway. Like, they're going to trigger enough to trigger your thresholds. Start high, work your way down if you feel comfortable on that. Definitely weight based on confidence. Some things are high confidence, some things are not, just by the nature of them. That's fine. Just build that into your system. And be ready. I'm going to go into an interesting failure we had right now because of this. Be ready for the weirdness that is the internet. Let me just give you an example. So how else could we increase cost? Hey, if someone's doing something bad, why are they even there in the first place? How can we just auto-ban accounts that are doing scanning? And so we did that as a hypothesis. We thought, okay, some attackers are going to do unauthenticated scanning, some are going to do authenticated, because in any application you can get way more exercise of the application by authenticated scans. So we went back and we looked at the numbers. And the thought was here that if we can force attackers to constantly create new accounts in addition to having to cycle IPs, that's a real cost. And especially if on the defensive side you feel like you've gotten pretty good tooling around detecting mass registration and things like that. So hey, if we're going to be able to, if we're forced them to have to create thousands of new accounts, and we feel that we're all right at detecting that, and we can close them pretty quickly, cool, that's another source of cost. So actually, while I was sitting in Nick's keynote this morning, I pulled our last 7 days of data, which you may extrapolate from that I was finishing these slides a few hours ago, but don't focus on that. From our last 7 days of data as of this morning, 437 scanners. How many of them were authenticated? Anybody want to take a guess?
Yes.
10. Were you sitting next to me? Where was I? It's 10. Awesome. You.
All of them by him.
Yeah, exactly. Wait a minute. Suspiciously. Why did they all say? Okay. Want to guess what our false positive rate on this was? Or our we would not have wanted to ban them rate? Yeah. Yeah. How many James Wiggett 1 through 10 accounts did we not want? It was 50%. It's crazy. These were legitimate users. This blew our minds. Like, we expected this number, right? You expect it to be low, even lower than you think of, like people are going to create an account and pipe in the session cookies and fly it through their scanner and things like that, because sessions time out, it's a pain. Like, the white hat guys know that. You have to deal with that commercially. It sucks. It's a pain. This we were not prepared to deal with. This is, like browser plugins, is honestly our best guess. We're pretty sure on that. But you can go back and 50% of those users were clearly legitimate. They were users who had been there for years, who have made purchases. Like, they were as legitimate as users could be. They weren't doing anything bad on the site in any other place. It was clear that their browser was owned. And so if you're going to auto-ban accounts, it turns out, nope, that facepalm, right? That would totally fail. You would start banning legitimate users all over the place. And the point of all of this, and my closing thought, this is as close to a conclusion as it gets, is that attacks don't always happen like you expect. Going back and looking at the data, and hopefully looking at the data before you make those decisions. If we had just decided to start auto-banning, because on the surface it seemed legit, we would have started just breaking users left and right. And the more instrumentation that you have gives you the context and the confidence to actually make those decisions. And you're awesome. Go for it.
So how were their browsers compromised? What point do you have any idea?
No idea.
That's really interesting.
Yeah, it was nuts. It's like they do requests that would trigger this. We can follow backwards. I'll even show you some examples. They do requests that definitely trigger this, that are clearly not initiated by the user. Almost certainly coming from the browser. We can't actually tell that because it may just be coming from malware, like living on the host hitting us directly. That doesn't really make any sense. Like, it should be in the browser.
Were they all the same browser? Were they all Chrome? Were they all Firefox?
They weren't, but I don't have numbers for you. This is actually something we were packing on the last few days.
I just think
So
it's like a bad Chrome extension that somehow, like.
the patterns, we saw a lot of different patterns. So I don't think that it was all the same thing, because you see some that are like clearly one thing. This one thing like requests XML/XML RPC all the time. Clearly legit users, clearly legit browsers, does thousands of requests to /XML RPC. Yeah, no idea what that is. Back there.
I have two questions. For the last part, wouldn't isn't it still a net positive to do that? Maybe do a temporary ban, 24 hours, or something like that, and alert the user that they might be compromised. Wouldn't that still be a?
Kind of depends on your site.
Yeah.
Your discussion forum, maybe? Are you an e-commerce site?
Yeah. And my second one is, where are you doing the instrumentation on the rate limiting, the detection of the scanners, and the check, the looking at the input for bad
Scanner baddies?
Yeah.
Yeah. The question was like, where are we doing this? We're doing it in our framework. It's one of the first things that when a request comes into our stack that it runs through. So it's right up top. It's really before you even hit like general application code.
Or no, when you said you did, you checked the inputs and you compare it to what comes out in the DOM. Where do you do that?
The check at the end goes out in your templating, so it's watching there, and the check at the beginning is in the framework. More questions? Yeah.
I saw Kenny's thing on content security policy
Yeah,
for
awesome.
XSS, and you talked quite a bit about XSS. So
Probably too much about it.
what are you guys seeing as exploitation with it? I mean, you're talking about detection, but clearly somebody's trying to get exploit run on you guys. So what are you seeing?
Yeah, so we have one of the nice ways to generate a lot of this data is run a bug bounty program, and the internet shows up. It's great. If you really hate sleeping, I recommend it highly. So that definitely generates a lot of things that we see in the bug bounty program. We've seen, knock on wood, we've seen almost entirely white hat behavior, but you don't know that. And the ones that have, like, the ones that are some of the most vexing things that I'd love to figure out but never will, are we've watched people find vulns on the site and then never write, like we know that they found them, and then they never write into the bounty or anything like that. I don't know. Like we fix them quick, and like we burn their vuln there. But you don't even see them come back in a large scale to that even later on. It's like you definitely found an XSS there. You didn't write in. What's going on there? That's an interesting one.
So I know there's quite a few folks that are working on like bots that they can run through XSS vulns, and I'm just wondering if you're seeing that behavior or not.
Like automated detection, or like bots to.
No, running bots to do anything. So they're just using your cross-site scripting problem as a way to either feed a bot, run a bot.
Oh, okay. Yeah, okay, yeah, distribute malware. Sure. Yeah, that's a good thought. Could have been it. It's weird because you'll never know on that one, right? Like someone found a vuln, they never told you about it. The other ones that we had there that were nice were in the beginning. This one dude, Damon, who's awesome, found this XSS vuln on like a Friday. He wrote it up on Reddit NetSec like a year and a half ago, and it was really cool because Nick G and I were hanging out and watched this guy find an XSS, and it was cool. And then he spent time building up like a really good payload to show like a really good proof of concept. This was before we had the bounty program. Built up a really cool proof of concept to show like, oh, here's me. You click this link, it'll flip your privacy settings so everything becomes public and extract like an email address. And like, it's good. He spent a lot of time on it and everything like that. We watched him find it and we pushed a fix before he had a chance to report it to us, which was fun and like a really exciting point in my early AppSec career. And then he wrote in on like the Monday. And he wrote in, he's like, my proof of concept stopped working over the weekend. That seems a little bit suspicious timing. I want to let you guys know I was not black hatting here, like, just so we're all cool about this. That's my home IP, like, everything's legit. And here's the details of the bug report that I had ready to go for you guys on Monday morning. And it was cool. We had like a really good dynamic with them. And actually one of the things I'm most proud of in our security program was that when we launched our bounty program, we went back and retroactively bountied him and a few of the other guys who had found cool stuff. before we had the program. Cool, more questions? Uh-oh.
Just drop, or do you throw in the random sweep one in there on negative stuff? Or
That's, yeah, okay.
I guess I could experimentally find out.
Yeah, this is not an offer to anyone to go find that. Yeah, that's the part I maybe intentionally or unintentionally not include is, cool, this is all about increasing cost, right? One of the next logical steps you could come to in increasing cost is injecting false results into data sets. And with that, I will shut the hell up on that topic.
Always happy to help.
Yeah.
How do you feed inputs to the HTTP form posts?
Mm-hmm.
Like, how do you automate that, or do you, in other words, like when you're trying to get a work to reflect and play back to you,
Mm-hmm.
do you just do that manually, that all manual testing for every form that you guys have?
Oh, when we're testing for XSS?
Yeah.
So the way that we approach this, and I have a previous talk on that, it talks about how you go about trying to do that at the framework level, and a lot of people are doing really interesting work there, like far aside from us. But in our platform, XSS is mostly killed by default in the framework level, and then you can grep for exceptions to that, which is what's fantastic, right? So if everything's escaped by default, you grep for what's unescaped. Or what has made that output be unescaped, and that's how we look for XSS.
Okay, so it's like logging on the server side, you probably do it that way.
Yeah, it's grepping the code base.
So you're using the users, or the user traffic.
Oh, for that one that we're doing for the reflected XSS, yeah, we're using the user traffic because you look at the hostile input come in and you look and see if it went out unescaped, and then you know that something happened there. We missed something in the code, and it came out unescaped and actually fired as HTML.
Okay.
Cool. Keep them going. More. I think I got a couple minutes left.
Do you automate that? Like, if you find one, do you have that at least run like as an automated test afterwards, like that particular request?
That alert is completely automated. Like all of that happens on every request.
Okay.
And then if it then logs a result, if it just found reflected XSS, and that triggers an alert, and that bubbles up.
Okay.
Yeah.
I apologize if I missed this or not, but do you guys run your own automated scanners for all these types of attacks? And if so, are you whitelisting them, or do you say, we don't need automated scanners, we have all of this in place, it's giving us all the data we need, and we're fixing them in that way?
Yeah, the internet is a really good automated scanner, it turns out. Sometimes you just don't get the vulnerability reports. We've experimented with them in the past. We've done in the past. Honestly, to set up the infrastructure for it to be able to really have it be fully automated and not something that somebody has to tend to manually at all. You do it, we didn't spend the time on it. We felt like it was a bit of a time sink, and we focused on some other efforts there. Not to say that we won't go back to do it, and explicitly not to say that it doesn't have value in other environments, because I've seen it have value. In ours, it wasn't the right place, it wasn't the right time, and we feel that we're getting good coverage and value in other spots. More? Yeah?
Have you guys thought of or tried using a WAF to kind of find some of the same stuff that you're finding?
Sure. The question was, have you thought of using a WAF? We've taken the concepts of a WAF that we like and built them into our application for the most part. And where I actually see, I used to be on offense, so that probably would have set me off before, right? Of anyone on offense just has generally a different opinion about WAFs. The one thing that I think that they can conceptually do well is in environments where you can't patch quickly, and it's a very kind of clean bug in that this is a zip code field and it has SQL injection. Well, it's pretty easy to then apply the regex that says you get 5 digits or you get 9 digits. And that's it, you only get digits. I think WAFs have value there of hey, I can't patch, this app has a 6-month release cycle. So even though that patch is clean, it's gonna go out in December. And that's where a WAF can do well. The other sides of it, we solve that capability by being able to deploy quick. So if you don't know the Etsy spiel, we deploy to production about 30 times a day. And so we can respond pretty quickly on those where we want to. And then for detection and instrumentation, things like that, we've focused on building that in. Yeah?
So it's easy to see how you find that, this field is accepting cross-site, you can filter on it, those little tactile decisions. Have you found any large-scale design or architecture stuff that, maybe we need to put this behind a login screen because Has it led to any sort of larger assessment of
Yeah, certainly areas that trigger vulns that you don't expect your stack to have trigger much larger security assessments. That's one of the big takeaways of a bug bounty program, is that before you launch, not to veer this too hard, but before you launch a bug bounty program, come up with a list of vulnerability classes that you expect to have, and kind of a weighting of that. I expect 1 million DOM XSS, I expect 2 SQL injection. And then match reality to that. A month out, holy crap, I had 50 SQL injection. I have that systemically, I need to go do something more about that. We've absolutely had it both on a vulnerability class level and on an area of the code base level of like, I'll give you like a brutal example of that is like, a vuln report will come in, it will look very real, and you'll look at it and go, not that like, oh, that bug is worthless or something like that, but what is that endpoint? Like, what is that function? Everyone looks around the table, is like, I've never even heard of that. And that goes and triggers very quick internal pen tests and things like that. Of like, what is that area of the code base? Is that in like a completely different repo, but publicly accessible? Definitely. You should absolutely be using your vulnerability information, not just as like tactically as spot fixes, but driving both what do I have systemically and what do I not, so that I can address that at framework level, and what are the dangerous areas of my code base in general, like in aggregate. Like that area over there is dangerous, has a lot of vulns. This area is new, clean code that doesn't. What should I be doing over there? All right, I'm probably totally out of time. I'll stand outside the room if you guys have questions. Thank you.